Good evening, students. I am Mrs. Parvati, PGT Physics, Holy Hearts Education Academy, Raipur, Chhattisgarh. In last episode, we have derived electric field intensity due to a conducting charged spherical shell. Now, we are going to derive the expression for electric field intensity E due to uniformly charged infinite plane sheet, thin sheet. Right? So, plane sheet means you may ask how it is. So, I would like to show you like this. This is plane sheet. The charge is uniformly distributed on both sides. I take this sheet perpendicular to the plane of paper. So, there are two surfaces here. It's clear? And having the area of cross section A is here, and here also area of cross section is A. Thin sheet, infinite length, I am not showing it, infinite length it is having, infinite plane sheet of charge. Right? Let us consider a Gaussian surface. So that's why I have drawn here like this. It is perpendicular to the plane of the sheet. I kept the sheet like this, perpendicular to the plane of the paper. That is why I have drawn like this. Consider Gaussian surface on the either side, this side also and this side also, whose area of cross section is A. Here and here also area of cross section is A. Sorry. Got it? Since it is infinite infinite length it has got, we can't take the entire length of Gaussian surface here. Okay. So, let us take whose area of cross section of Gaussian surface is A. So, both the sides I will take because the flux is radially this side and I have shown already the sheet here. If due to this charge, electric field lines are this side, perpendicular to the surface, and due to this side, the perpendicular to this side here like this. So, both the lines we have to calculate, both the flux we have to calculate, both the sides. Flux we are supposed to calculate. That is why we have taken two surfaces. One is this and another is this one here. So, what is the total flux of these Gaussian surfaces here? Phi 1 is equal. What is phi 1? Phi 1 is equal to E into A. It is uniformly distributed charge on both sides. So, E is constant and we know Gaussian surface formula. The properties, E is constant and theta is 0. Don't forget that. So, phi 1 is equal to E into A, phi 2 is equal to E into A. The total flux phi E is given by phi 1 plus phi 2, which is equal to EA plus EA, 2 EA we got. Right? According to Gauss theorem, integral E dot ds phi E is equal to Q by epsilon naught, which is equal to sigma A by epsilon naught. Why we are supposed to take not Q and why sigma here? The reason is it is of infinite length. We can't calculate the entire charge present on the plane sheet, infinite length. So that is why we take charge density A, sigma, surface charge density, we will take sigma into A and upon epsilon naught here. So, what is this value phi E? Just now we calculated 2 into EA is equal to sigma A by epsilon naught. A and A gets cancelled. So, what is left here? Sigma is equal to, that is E is equal to sigma by 2 epsilon naught. In vector form, we can write sigma by 2 epsilon naught into unit vector n. You know unit vector direction is outward here, both the surfaces. So, in this way we calculate the thin sheet. Suppose if you want to calculate the thick sheet, I would like to show you what is the example of thick sheet. Thick sheet is like this. See here, thick sheet. This is one thin sheet and thin sheet. How many surfaces here? We have already calculated. One is this side, one field is this side. This is sigma by 2 epsilon naught. Here also sigma by 2 epsilon naught, sigma by 2 epsilon naught. So we have to add up these two here. So accordingly I have drawn the diagram. Next derivation is E due to uniformly charged plane sheet, but it is thick. So I have drawn the diagram here. You know this is the normal and electric field. Here also normal electric field. Inside also there is electric field here in both the sides here. Right? So we know that according to Gauss law, E is equal to E1 plus E2, both the regions. What is E1? Sigma by 2 epsilon naught, just now we have derived. And what is E2? Sigma by 2 epsilon naught. So that is answer is E due to the thick sheet is given by sigma by epsilon naught and unit vector n here. Outward drawn, the normal drawn the outward here. So this is, in this way we are able to find out the electric field intensity due to a plain sheet. Sigma by 2 epsilon naught for thin sheet, and for thick sheet it is sigma by epsilon naught. Thank you. Bye bye.